along with ChampCar Live. We're down here at Wilwood Brakes in Southern California. It's kind of sunny outside, but we're indoors right now talking to Mike Hamrick, who's going to show us some hubs for the Mazda Miata. So explain these new hubs that you designed after racing in ChampCar.
So what it came down to is we found that the weakest link on the front of the car that we race was actually the hub. So we tried a bunch of different OEM hubs and heat-treated hubs, but kept finding that we were having instances where the backside of the flange was literally breaking off.
Right.
And something that Dana explained was he's running a 245 tire.
Right.
On a car that's flat-footed around a course where you can get a lot of G-forces. So it wasn't so much with trying to make the car stop better in this case. It was actually more to make the thing last for 2 days of racing.
Right.
So what Bill Wood, the owner, came back and started talking to our engineers about was coming up with a plan that we could make a hub that's going to be able to survive. The nice thing is we go out and test it on our own vehicle, so we're getting a lot of feedback directly from our drivers. And what was really nice is, in order to get the packaging properly, we currently use one of our net forged hubs. So the reason that using a net forged piece is so much better than using a piece of billet is, when we forge this part, you can see the grain structure goes along with the flow of the component.
Right.
So that when you're machining into it, you're going with the flow instead of cutting into the flow. So it makes for a much stronger part. That's why buying a forged piston is so much better than a billet piston nowadays, or an axle. So you can kind of see where we're typically making these hubs for is going to be our street and hot rod and muscle car marketplace. But they were able to get this hub out of this forging, which a lot of people are amazed at. From the design factor, we also go and do FEA testing to make sure that the thing's going to be able to take the loads. Now, I will be honest and tell you that one or two of the first prototypes, we found that we needed to make some substantial changes. We found some fatigue in them. Mm-hmm. But that's, again, the good thing about us being a part of ChampCar and coming out and working with other teams. Getting this knowledge firsthand is really important. So this has now become the hub that we're going to market with. Forged aluminum. I realize that you really like the whole threaded in stud idea.
I did, yes. Their studs actually thread in, which makes it so much quicker when you're servicing something in the paddock.
So that's one of the things that we do across the board with most of our hubs. The other thing that we found was during the initial testing, we believe that we were torquing the lock nut or the spindle nut too tight. So after doing some testing, you have to realize that this hub is going to expand and contract under heat. Mm-hmm. So after 6 hours of racing, expansion and contraction coming into the pits, a lot of people don't realize also that as you're sitting in the pits, typically your brakes get hotter because there's no airflow. Well, the same thing happens to this hub. All of that temperature is getting transmitted into the hub, so it's expanding until you get back out on course. So what we found is getting the correct nut torque specification and then backing it off. Well, once you back it off 1 to 3 thousandths, which we include in the instructions, the special jam nut or the special washer nut assembly that we provide that fits down into the bearing, which is not cooperating with me.
Well, that's good. It's a nice tight fit. It's supposed to be. There should be no play. There you go.
So once it's on there, you can see that this keyway, once the nut's been backed off again, you can set the keyway just like we do in a lot of our circle track applications, and then set these at 20 inch-pounds to set this washer so that the nut will not back off. So that was a really crucial thing that we learned during the development of this new product.
And you also use tapered bearings, where most cars, especially the Japanese cars nowadays, still use the ball bearings. The tapered bearings really...
They take a lot more side load.
Yep.
Yeah. And the other thing that I realized after we started the development is that the OD of the bearing was just about the same size. So that means that the stress level but because we've got so much more surface
Right.
area, is so much greater for a road race application like ChampCar racing.
Right. Now seals, this whole kit comes with the seals required to make it work. I think that goes on the other side.
Yep.
Yep, right in there. It's got bearings that you can replace, or the races that you can replace, so when you rebuild it. And then of course the nice little finishing cap on the outside, which is a nice little finish. When you see it on a wheel, we'll show you a picture of the finished item on a Wilwood race car, one of the Champ cars. It's a sweet little setup.
And a couple things that I've realized we've gone that extra mile on is even including the metric bolt so that you can release the cap.
Ah, right.
You know, just little things like that, and it's because we've been a part of your racing association and going out and driving this stuff, we're able to come back, dissect it, and see exactly where the links that need to be fixed are.
Now, one of the great things about racing with the other racers out there is you'll discover something that they're doing that you never thought of, and then you can implement that into the product itself.
Exactly, and that's why it's so crucial as a sponsor of the series to be at these events. We wish we could be at more of them, and we're going to try to be at more of them, especially on the East Coast. But here on the West Coast, it's been really valuable because we'll see someone's not using the right compound pad.
Right.
And it doesn't even have to be a Wilwood component. It can just be a factory type of caliper. But we're able to explain to them, hey, you're going to have a much better experience.
Right.
That's what we're trying to sell these people is, hey, we're not trying to make you go out and win your first race. You're not going to.
Right.
Okay, and if you do, then wow, you've done some other racing.
Right.
But going out and having a really good time and then learning from this so that you can move on to other types of road racing as well.
Right. Now with your brake systems like we have back here, we have the four piston Wilwoods are just a few points with ChampCar. If you use them, I believe it's 10 points. But the difference in running something like this versus OE is that the pad material is a lot cheaper because it's all standardized. So the overall cost of running the brakes is cheaper, and the calipers aren't that much more than OE than buying new OE.
And that's what a lot of people don't realize. The way that we do our manufacturing is in large quantities, as you saw today. So we're able to take one caliper and use it in a lot of different marketplaces. So we're able to mass produce the caliper with the same technology that we've always used. Right. But in a series like yourself, keep in mind that the main importance of going to, say, a fixed mount caliper over an OE floating caliper is, first off, what I've always noticed in a race car is pedal feel. You have a much more positive, less compliance. You're taking all of this pushing and pulling out of the system. And the big factor that I find when I really get down to brass tacks is we're scrubbing a bunch of unsprung and rotational mass out of the system.
Right.
So the ease of pads and trying different pads is a lot easier. Let's say just in our own ChampCar, which uses the Dynalite series caliper, we offer 12, maybe 13 different friction materials.
Okay.
Now, I'm going to say that 4 of those would not be eligible to use for road racing. But you're talking 7 to 8 different compounds that you can really dial in the driver to the use. And with multiple drivers as well, that's really important because then you can go out and do a test day and get all 4 of your drivers on the same material so that it's all you have to do is adjust seats when you get that new driver in.
Right. Now, the rotor material you guys sell, the rotor, the two-piece, the hats aren't all that much money, and the rotors, I'm being told there's something like $65 at Summit for the actual bolt-on rotors.
So like on the Miata application, the replacement disc in a straight vane, which is going to be our most affordable, you're looking at about $65.
Right.
But the nice thing is we've got about 3 different upgraded rotors, all the way to our Spec 37 material, which is a proprietary material that we use in all of our race applications. That rotor is going to get you closer to $100.
Right.
But, and this sounds strange, but you can even feel a difference in pedal feel between the same brake pad on a straight vane rotor, which is our mass-produced rotor, compared to a Spec 37 material rotor. And it's because sometimes the machining is done a little bit differently, but that's what you're paying for. Also, the Spec 37 material, it's going to be either directional or straight vane, but it'll be a staggered vane like this one is.
Okay.
So we've got more surface area. So it's going to cool better. So there's a lot of things that we build into the more expensive rotor that's going to give you a better outcome as far as performance.
So something like this straight vane would be the lower cost.
Correct.
Cool. Now, for guys looking at streetcar applications, they're looking at e-brakes. Do you guys have different sort of e-brakes out there for them?
So like this is going to be one of the MC4 calipers that we offer, which would be a standalone caliper. That will be your stomping. Then we can go into like this particular kit. This is more of a muscle car application where we make it for different flanges with different offsets to set the caliper centered over the rotor. So this is what you're going to find on, like, let's say a 69 Camaro with a 15-inch wheel. And the nice thing is that if you can look inside here, there's an internal drum with drum shoes. So that's what's doing our parking brake for us.
So those that know me know that this would be the one that I would use on the Opel GT.
Is it a solid axle?
It's a solid axle, yeah.
Yep.
And this is where Dana drops the camera from laughing.
Cool. So Mike, with ChampCar, we have a lot of guys that are looking at the hot setup now would be standalone pedal setups. We're requiring the dash bar in 2 years, so they can actually go to a separate brake pedal system for their cars. Now you guys offer different types. You have the floor mount, you got the hanging ones, which are on the other side over there. I've never done this before. I don't really know the benefits of each one. Who do I call to help me out with this?
So here in the main facility in Camarillo, we have about 15 guys, Monday through Friday from 7:30 to 4:30 in the afternoon that can take any of your phone calls. Keep in mind that the majority of our parts, and when I say majority, I mean 99.9% of our components and parts have technical drawings. They have everything online that you would need in order to fabricate it into your vehicle. So we have a lot of distributors that will go as far as sourcing exactly what pedal assembly may work, especially with the dash bar that you're going to be telling everybody to run. With that in perspective, going to its own standalone pedal assembly is going to be a really good idea for those guys.
Right.
Giving us a call, we can go through and get you all the data you'll need. And the data that you're going to need are, first and foremost, what I've learned is having the correct ergonomics.
Right.
A lot of people get into building a car in general, and they don't think about how much am I going to drive a car? How much seat time is it going to be that I need to be comfortable so that I can really focus on what is at hand? Now, that could be a hot rod.
Right.
Okay. Are you going to drive across country? Because you better make that hot rod real comfortable.
Right.
Or it could be a ChampCar, and I'm going to be running for 6 hours with 3 different drivers. That means 2 hours of seat time.
And different size drivers, too.
Yes,
So.
and that's very tough. So, in some cases, a floor mount may be better than a hanging. And then as far as hanging, we've got forward mount, which means that the master cylinders would be on the firewall side, or reverse mount, which you're going to find in a lot of real race cars, so that we keep the master cylinders inside the cockpit of the car. So we can step you through and get you as much information on what's going to work best for ergonomics. But the really important thing is, if you go to a balance bar or a true bar pedal assembly, getting the right or correct bore size master cylinders.
Right.
And again, here's what I'm constantly telling people is, after I go through and I tech out what pedal's going to work with what leverage, and I find out what brakes are on the car, my next question typically is, what size person is going to drive this car?
Right.
Okay. Is it going to be a 5'2" guy or a 7' guy? Because a guy that's 7 feet, he's going to need a totally different bore size master cylinder than a guy that's only 5 foot tall.
Is that because of the amount of leverage he's putting on?
Totally.
Yeah.
We talked about somebody earlier that we both know who's 7'1".
Yeah.
When I helped with the builder selecting master cylinder bore sizes, I had to keep that in perspective. Whereas the builder, who's a shoe, and this is a pro touring car, the builder who knows how to drive pretty well, he kind of complained to me. He's also a friend, but he complained. He goes, man, the pedal's really firm. It's not like my car. I said, well, because we had to build it for the driver. Right? Not for you, but for the 7'1" guy. So the tough thing about endurance racing is trying to make sure that the ergonomics are going to work for your 5'2" guy and your 7'1" guy.
See, that's something out of the ordinary for racing, because usually racing is zero compromise, whereas endurance racing, you have to have a compromise.
You have to. Well, think about Alex Zanardi.
Oh yeah.
You know, that is a prime example of watching Daytona this year, and I was so excited because of his ChampCar background and kart series, that he has made such an impression in Europe with road racing that they had to build that BMW so that multiple drivers could drive it.
Right. Not just him.
Yeah. You know, so that's a very good example of ergonomics and how important it is for all of the needed drivers to be comfortable.
Yeah, we have a Miata driver as well that had an amputee, and he was racing in our 24-hour last year, and the same thing. So multiple drivers, not just him. So the compromise there. Well, thank you, Mike, for showing us around. And
you got it.
Hopefully we can get. We're working on the points for the Miata hubs, and guys can get the Miata hubs racing here soon. So thank you very much, and we'll see you at the next race.
Sounds good.